Hey everyone, how are you all? I am Smita, your PM mate, and you are watching Top Physics News only on Physics Mind Bowler. In this video, I am going to talk about modular quantum brain sensor, internal structure of proton and their collisions, and asteroid 16 Psyche. So, let's begin. First, let's talk about modular quantum brain scanner. The researchers at the University of Sussex have built a quantum brain image technology for the first time to detect brain signal. A brain signal is detected for the first time using a modular quantum brain scanner, and this is the biggest milestone for the researchers working in quantum image brain technology. The team have connected these two sensors like a Lego bricks, and proving a whole brain image technology using this method is within reach. These modular devices work like a play bricks that they can be connected together. This opens up the potential for whole brain scanning quantum technology and potential advancement in neurodegenerative diseases like Alzheimer's diseases. These devices built in quantum devices and system laboratory in university, they used ultra-sensitive quantum sensor to pick up this tiniest magnetic field to see inside the human brain to map the neural activity. The team applied these sensors at the outside of the scan of participant near the visual cortex of the brain. They asked a participant to open and close up their eyes for 10 to 20 seconds of interval, and they were able to detect signals. This is a very simple action, but to see it happening inside the brain from outside, it needs a highly sophisticated quantum technology. Sir Thomas Quissens from the University of Sussex, who have built this sensor, have said that our sensors have to be exceptionally sensitive to pick up this magnetic field in the brain because it is very big. The magnetic field inside the brain is trillion times lower than that of the fringe magnet. A magnetic quantum sensor uses optically pumped magnetometer in magnetic sheet to reduce environmental magnetic field to ensure that they are not being getting detected. In simple words, a sensor works like putting a vapor into the quantum states and shining a laser beam through it and using a photodetector to see how light has gone through. How atomic vapor interacts with laser light sensitively depends on small magnetic field. A small electric current passing through the nervous system of brain leads to the magnetic field even outside the brain, which was getting detected by the brain signal. Now, let's talk about internal structure of proton. Inside each proton and neutron, there are 3 quarks bound by gluons. Until now, it has been assumed that 2 of them form a stable pair known as a diquark. In the recent research, the significant role played by the interaction of gluon emitted by the proton from the sea of virtual quarks and antiquarks appearing and disappearing inside one another of proton and neutron. There are 4 fundamental forces present in nature: strong force, weak force, gravitational force, and electromagnetic force. Every forces has their own carriers. Gluons are the carriers of strong forces. This binds the quarks into composite structures of proton and neutron. With respect to others, strong forces are different from other. Strong forces doesn't get weakened, but it goes by the distance between 2 particles. Dr. Andres says that the gluon exchange model, that is GEM, has allowed us to explore the scenario of the course involving event of protons and neutrons. For example, let's imagine the short proton-proton collision in which a proton emits a gluon that hits the another proton, not a valence quark, but the quark from the sea of virtual quarks and antiquarks that present for the moment of inertia. When such gluon absorbs the sea of virtual quarks and antiquarks, forming a pair cease to be virtual and materialize into the material that present in a specific metal state. Now, let's talk about our third topic, asteroid 16 Psyche. A widely studied metallic asteroid known as the 16 Psyche was long thought to be exposed iron core of a small planet that failed to form during the earliest days of solar system. A study led at the University of Arizona suggests that this asteroid might not be as metallic and as dense as once thought, but it hints at a much different origin story. Scientists are interested to learn about 16 Psyche because if its presumed stories were true, it will provide an opportunity to learn about exposed planetary core. NASA has launched Psyche mission by 2022 and to reach asteroid by 2026. Undergraduate student of University of Arizona, David Candilo, who is the lead author of a paper published in Planetary Journal, suggests that 16 Psyche is made up of 82.5% metal, then 7% of low iron pyroxene and 10.5% carbonaceous chondrite, which was likely to be delivered by the other asteroids. Sir Chondrite said that having a lower metallic content on an asteroid means the asteroid could have been exposed to the collision of an asteroid containing common chondrite carbonaceous material that is deposited on the asteroid that we are observing today. The past estimates of the 16 Psyche composition were done by analyzing the reflected sunlight pattern. The pattern of the reflected sunlight were matched with the metallic object. The Candelo and their collaborator instead made a 16 Psyche regolith, that is a loose rocky material, in the lab by mixing different materials in lab and analyzing their light patterns with the observation made using telescope of the asteroids. There are very few labs in the world using this technique. First is University of Arizona of Lunar and Planetary Lab, and second one is John Hopkins Applied Laboratory in the Maryland. The researchers have observed that carbonaceous chondrite material present on the asteroids are rich in water. So, they are trying to merge the database from the ground telescope and the spacecraft mission to determine the amount of water present on the asteroid. To know about more interesting facts of physics, you can check out our Instagram page on Instagram, follow this page and dive into the beauty of physics. So, this is it for today. See you in the next video. Till then, take care and goodbye.